This is IPv4 addressing and subnetting we are going to take. Whatever we are discussing today, in order to understand that, we need to know the binary to decimal and decimal to binary conversion. How does it work? Let us take an example. Say we have 23. So what do? We divide it by 2. And 2 ones are 2 and 2 ones are 2. So 2, 11. 1 is the remainder. So we put 1 as the remainder. Again, we divide it by 2. 2 5s are 10. Again, 1 is the remainder. Again, divided by 2. 2 2s are 4. 2 2s are 4. And you get 1 as the remainder. Now 2 1s are 2. And then 0 is the remainder. This is 0. Now, I'll just come back to this. This is one method. I'm going to complete it. But before that, if I want to write 23, what are the other options? 23, can we write it in the 2 to the form, some addition of 2 to the power form? Yes. We have all these. So can we have some combination that makes 23? 23, we can write it as 16. And plus, if you add 4 more. Okay, now 16 and 4 we have taken. So this is 20. We need 3 more. So 2 and 1. So we can write 23 as 16, 4, 2 and 1. Okay. And these are the positions where you have to put 1. These are the numbers coming from 2 to the power. Why 2? Because it is binary. Binary means 2s, 1 and 0. So for 2, every position has 2 to the power something. The first position is 1. The result has come from 2 to the power 0, 2 raised power 0. If you make 2 to the power 1, it will be 2. If you make 2 raised to 3, I'll write 2 to the power 2 just now. 2 to the power 4 is 16. 2 to the power 5 is 32. 2 to the power 6 is 64. 2 raised 7 is 128. Now you will ask me question, why only 7? Why only 8? We are talking about 8-bit number here. So 1 is there, 2 to the power 0 or 1. Now you have to put 1 here. Because we have taken 2, so you put 1 at position 2. 4 we have taken, 2 to the power 2 is 4. So put 1 here. You put a 1 here. Then 8 we have not taken, so put 0 here. 16 we have taken, put 1 here. 32 we haven't taken, 64, 128 we haven't taken, so 0, 0. These are the representation of 23 in binary form. Actually, I took a decimal number, 23, and I converted it into a binary number of 8-bit. I hope you remember I started with this. You have to take these numbers in backward manner. 1, 0, 1, 1, 1. And all the zeros in the front to make it as 8-bit number. To make it as 8-bit binary formation. These two are exactly same. So either you use this technique or this technique. Both way you can convert decimal to binary. Now, how to convert the binary to decimal? I showed you the method. Now you can directly do. Same thing you have to do. It is 1. So this is binary. If this is the question in front of you, that this is in binary, you want to find out the decimal. So just multiply this 1 because it is 1 in the first position. So multiply 1 with 2 to the power 0. Multiply 1 with 1. So you get 1. Multiply 1 with 2, you get 2. Multiply 1 with 4, you get 4. Multiply 0 with 8, you get 0. Multiply 1 with 16, you get 16. Now multiply 0, 0, 0 with all these 3, you get 0. Now add all these, and you will finally reach binary to decimal. This is 23. This is 23. Okay. Now this formation, again, let me tell you, these are the bit positions. 8-bit. We have taken 2 to the power this bit position. So binary means, as I said, 0 and 1, 2. That is why we are taking always 2 to the power. And these are the bit positions. So that is why we have all the numbers with binary. So 2 raised to power n the bit positions. And that you compute, and these values which you see here are used for that. What are IP addresses? IP address in a network or a host. So it's a network and host address. So the question arises, what is a network? What is a host? If you have an organization, say this first one, there is a university. This organization has a network N1. This university has a network N2. Here they have many computers. In your organization, there are say four computers. These many computers are known as host. These 4 computers you have in your university are host. This is the difference, and this is the term network and host. So now there are so many hosts here, and they would like to divide it also. So that is subnetting. Means a whole network is divided into multiple parts. It's subnetting. Or whenever we talk about host, it is a computer on which you are sitting or I am sitting, or a gadget, or say a air condition which works on IP, so that a remote person sitting can also repair the AC. Now in the second network also, every network, whichever it be, every network has a network ID and a host ID. ID means identification. So this host, every host had some ID, and then network ID. These 2 defines in which network that host or that computer system is. So IP is simply network ID and host ID. Network ID we always write on left. Host ID we always write on right. And what is a subnet mask then? See, if you are suffering from coronavirus or you want to save yourself, you put a mask. You put a mask, so you try to hide. This is a 32-bit number. So this subnet mask is associated with each IP address. The subnet mask identifies in this whole block which one is the network portion and which one is the host ID. So if you are given a 32-bit number, how you are going to find out the network ID and host ID? For that, you need a subnet mask. The work of subnet mask is to give you from a bit stream, which is the network ID, network portion. So in binary form, the subnet mark is always a series of 1, always 1, followed by 0. A simple decimal mask, for example, is this. This is a class C. I'll come to that. 255. This 255. Whenever we take 8-bit, 2 to the power 8 is the maximum. Whenever we take 8-bit, 2 to the power 8 is maximum. And which is going to be, what is the maximum value? 2 to the power 8. It's 0.0000000 is the lowest one. This is the lowest value. Okay. If you take the decimal equivalent, it will be 0. What is the maximum? 2 to the power 8. 1, 1, 1, 1, 1. See, all zeros minimum, all 1 maximum. 1, 1, 1, 1. If you take the decimal, you are going to get 255. 2 to the power 8 is 256. But we start from 1. Then we go up to 256. But we are starting from 0. That is why the maximum will be 255. So this is going to be clear just now. In a computer or a digital device, knows only 0 and 1. Only 0 and 1, any digital device. They don't understand anything else. So an IP address in IP version 4 has 32 bits. This 32 bits, we just don't write in a stream. We write 8-bit, followed by 8-bit, followed by 8 another bit, followed by 8-bit. 8-bit is a byte, so 4 bytes actually. And in between we have a period. We have a dot. This 8 is octal. 8 means oct. So octet. Let us call it as octet. There are 4 octets here. There are 4 octets. If you see here, 1, 2, 3, 4, 5, 6, 7, 8. These are 8 bits first octet, 8 bit. Second, this is a decimal, this is a period. Second one, it's a 8 bit again. Third one, 8 bit again. Fourth one, 8 bit again. In between we have dot. Period here is dot. So we have 8 bits. In between they have 3 dots. So every 4 octet, 8 bit, 8 for the 32. IP addresses, human beings, you and me. Why IP addresses are important? Why we require it? You and me, we don't remember number well. If I will ask you, give me my mobile number, you will go to the mobile, search my name, and you'll see the number and you will tell me. It's highly unlikely that you are going to remember my number. Females can, females can remember the numbers. I'm pretty sure about that. These big numbers, mobile numbers are 9 digit or 8 digit or 10 digit. But whenever we are talking about 32 bits, will you be able to remember these numbers? No, it's very difficult. For that, the people, human being, we don't like this bit stream, etc. We don't want this number. Now you just name this as www.google.com. I don't know it is Google or not, but still, anyone in the world, I doubt that they don't know Google. But this Google word is known to everyone. This IP is not known to us. So, human being knows number. How to know that number? We know the name. So, in order to do that, there is a number associated with each node, each point, each computer, so there is a number, so that is known to all over world network. That is called the IP address. So now we can convert this in binary equivalent. So these are 192.168.10.150. This is dotted decimal. Because we know name, we don't know the numbers, but the computer or the system knows IP address. IP address have two parts. IP address have two parts. One is network number. There are two parts. One is the network and one part is host number. So there can be multiple, hundreds of networks are there. Which is the network? And inside that network, which is the device, that is, which is the host. And this shows you, if you want to go into the network and inside that host, you need to know this. So in an IP address, what is the IP address? Let me make and show you a box. So here 192.168.10.150. Here, this portion from here to here, this is, we are saying that it is a network number. And from here to here, it's a host number. Network ID and host ID. What is the correct one? If you only have to write the network ID or network number, you will write only the N part, you will write 0 in H part. And when you are being asked how many hosts, what is the host ID, you write only 150, rest are 0. So for network part, you write 192.168.10. Up till here, this is network. After that, the host part you have to put as 0. This is your network number, network ID. And in the host part, only the host part is written, others are kept 0. IP addresses have different classes, A, B, C, D, E. D and V we are not discussing, they are reserved for something else. What we are dealing with is A, B, C. A, B, C. So we have A, B, C, A class, B class, C class. What does it mean? If the first octet, we have to only look at the first octet. So these are 4 octets. These are 4 octets with a dot. Now if you see the first octet, if this number is between 0 and 126, 0 and 126, whatever is coming after that, this is class A IP address. This is IP address we have known. Now I'm trying to classify it, right? So we have 123. If I write 123, it's class A. when I write 150, it's not class A. Now it has gone to class B. It has gone to class B. 128 till 191. If the first octet is this, then we say that this is 128, 199, 191, 150 lies in between. So it's a class B. It's a class B address. And C. Let me write it 220. 220. So if you see there, it's 220. It is not in B also. From 192 to 223, 220 is in between here. So there has to be a question in between in your mind. 128, 191, it's okay. 191, 192, okay. Where is 127? Between 126 and 128. Where is 127? This is reserved for loopback. Okay, this is loopback. The class D addresses are used for multicasting. They are used for group emailing, group broadcasting, and few IP addresses are reserved. Let me tell you about D also. This 127.0.0, this all is for loopback. And class E IP addresses are used for military purpose. That is why we are now discussing D and E. We are talking about A, B, C. To differentiate between the network portion as the host portion, network administrators, they use subnet mask. So in every class we have, all the class we discussed has a default subnet mask. So if for class A, class B, class C, as I said, D for group broadcasting, group emailing, class E for military purpose. So A, B, C we are taking. For A, the first octet is N, network, others are H, host. For class B, 2 are network, 2 are host. For C, 3 are for network and 1 is for the host. This is 255, as I said. Always network is 1111. Network 1111, 255. Network 255. This is for subnet mask, I'm saying. For host, the subnet mask will be 0000. So this 255 is subnet mask. Now when we mask or we take the logical end of this subnet mask with the any address which is maybe ABC. So when we are talking about C, if we logically AND our IP address with 255.255.255.0, we get the network ID. That is 1.1 and is 1, 1.0 you get 0. So that is why we took 1111 so that we get NNN. We need to get the network ID here. So what is the default subnet mark for the B? 255 because it has to be 111 for network and 000 for host. So for A, 255 for network, 000 for host. And class C, class B, class A has these subnet mask. So in the class C, as we see here, this is 255, 0. And when we take 11111 like this, 8 times, and then 000. We have 192.168.10.150. Now some user told me that this is the IP. Give me the network part. This is so first we'll convert these all decimal to binary, and then we convert this subnet mask to binary. We take the AND, logical AND. We get 192.168.10 as the first three octets. Wherever we have 255, we are going to get the same number. So 192 when we AND it with 255. But the last one will become 0 because we are adding 150 with 0, with all zeros at 8 bits. So this 192.168.10 is the network ID. So what I said just now, class A, there is a default subnet mask. In decimal, it is 255.0.0.0. Same in the binary form is this one. So this is network. In the second network. Third one, 3 octets. First 3 octets are network. And what is the subnet mask here? 255.0.0.0 because we only need to get the first octet. For class B, we need to have 2 octets. Class C, we don't want to find 3 octets. That is why we have to AND it with 255. Network numbers. The network number is the first address in an address range, and this is used to identify the network itself. See, if you have a network, first we have to find out if for any communication, we need to know the network. Okay. Now network varies from one number to another number. What about this network? What is the number of this or network number of this network? We start with 0, and we started with 0 to 126, first octet. So class A network, if I say class A network, if I have an example 155.0.0.0, so whichever is 115, the network number, it will be 0.0.1.2. It can be any host ID in this network. 115.0.120 is any host in this network. But what about the network itself? What about the network? I want the network ID of this network. There has to be a very specific representation to find out the network, because everything starts with a network. So the network ID of this network is 115.0.0.0. The first number of this range is the network address, is the address of that network. So we have 154.90.0.0. So it's a class B. So 154.90.0.0 is the network ID of that network. Similarly, one more example of C. You see first three are 221.64, 244. Last one is 0. So this is the initial address or actual address of the network. Now what is the last one? As I said, 115.0.120 was some host. 115.0.0.0 was the network number. That is the whole network number. What about the last number of this series? I want to send a single message to all the hosts which are present in this network. It may be 1 to 100 million. So the last IP of the range 115. Last one will be what? Highest is 255. So if I take class A, what it will be? Wherever 000 was, just take it as 255. 255. So this shows you network, and this is 00 is network, whole network, and this 255 is for broadcasting. So whenever we have a network, there will be whatever range you have borrowed, the first and last you cannot use. We cannot use the first and last one, because the first one is the network, the last one is for broadcast. All the numbers in between can be assigned to the host or the subnets, other networks, right? The inside host. The broadcast address is used to send message to all the hosts on the network. In a binary form, the broadcast address has all ones in the host portion of the address. All ones in the host portion. If you have a network number as 115.0.0.0, you put 0, you replace 0 by 255. It will be the broadcast address. Broadcast. Wherever you see 00, put 255. It will be a broadcast address of the same network. If you put 255.255.0, it will be the network number. So whenever we try to find out the range, what do you get? 2 to the power n minus 2. Because the first and last cannot be used. First is for network, last one is for broadcast. Host address. So see, whatever we have discussed, we have known about the network. Class A n, class B n, class C n. What about the host? So every host has to have a unique IP address. On internet or any network, and a host have to have a unique ID. So each host of the same network must also use the same subnet mask. This is also mandatory. If you take a network and you take a host, all have to have the same subnet mask. Okay, same subnet mask. This is using another mask. This is using another mask. That's not possible. When we are assigning IP address to hosts, we cannot assign the first and last address in the range. As I said, the first one was network, whole network number, and last one is the broadcast address. For example, the 115.0.0.0, this is a class A address. The range only available with you is 115.0.0.1, because this number which I wrote is a network number. The last one, which is 115.255.255.255, this I cannot use because this is a broadcast address. So we have range only. After this, what comes? 115.0.0.1, and just before that, what comes? 115.255.255.254. Same as with the class B. Here we have these two, 0, 1, and this 255.254. One below this 255. Same here. Actually, we are going to discuss subnet in the next discussion. Let me give you a brief idea about subnetting here. Now, subnetting is the process of dividing a large network into smaller network. Because as the network grows, it becomes bigger, we need to create subnets. We need to divide the network in smaller network. As the network will grow, there are certain problems. Increases the number of devices that can be added to the LAN if we create subnets. There are certain congestion problems that can be reduced creating subnets. The processing load can be reduced because we want to, first of all, the addresses are limited. We want to increase the range of the addresses. For that, we can use subnet, and also reducing the congestion and collision. Many nodes, many hosts, more problem, more congestion or collision, or there will be a processing node. Okay, so we can divide it in number of times. And as I said, most of the time we need to segregate also. For a computer science department, electronics department, we want to divide. And see, the faida or the benefit of creating subnet, we combine networks with different media types within the same internetwork. Because subnets cannot be used to combine networks of different media type on the same subnet. Please understand one more time. Subnets cannot be used to combine networks of different media type on the same subnet. And this we are going to use or see in the next discussion, because subnetting I am going to take with examples in the next discussion. It is not possible to use subnet masks that do not use an entire octet. For instance, the mask 255.255.252, it uses 6 extra binary bits in the third octet. Okay, so it is possible to use subnet masks that do not use an entire octet. Okay, so subnetting is dividing. We are borrowing, we are stealing some host bits, because network part we cannot change, but we steal, we borrow some bits from the host part, and then we make the subnet. We are going to see that a lot. But before we conclude, I'm going to tell you or give you some problem. So this is an IPv4 address, and then here you have to find out the network ID and host ID part. Network ID first. Also, you have to find out the class. Network ID, host ID. Now you just see here. This is 1. The first octet is what? 1. And this 1 lies between, is it lie between 0 and 126? Yes, it is class A. Therefore, it is class A. What is the network ID? The first is the 1 is the class. Only 1, N is there. So 1 is the network ID. And the third, rest 3 are host ID. So 455. Coming to this one, 130, 45, 151, 154. 130 comes in between 128 to 191. So it goes above 128. So 130 lies in the class B. And it is class B, the first 2 octets are reserved for network. And third, fourth are reserved for the host. So the first and second, network ID, it will be network ID. Host ID will be 151, 154. This is how you solve it. So there is an expression being given here. If you don't get a complete idea, just see here how and how you can find out the network ID and host ID. I explained already. Just for an overview, let me tell you again. If you know the classes, you can find out. The first one, network ID, class A, first octet. Class 2, the first 2 are the network ID. First 2 are the network ID. First 2 octet. Next 2 are host. Class C, first, second, third are the network ID. And the fourth is the host ID.